Today we're going to take a look at graphing shifts and reflections of functions. And I've broken it down into 3 steps, which will hopefully make this process much easier. The first step is you want to determine if there's any reflection going on within your function based off of the parent function. You could have reflection over the x-axis, the y-axis, both axes, or neither. So for this first example, we have a negative on the outside of the quantity containing the variable. If the negative's on the outside, it's going to control the x-axis reflection. Since it's negative, it's going to now, this parabola is going to open down. In the second example, the negative is on the inside of the quantity that contains the variable. Since it's on the inside, that's going to control reflection over the y-axis. Right. Once you determine the reflections, you want to determine if there's any shifts. To determine that horizontal shift, you take the quantity that's being squared, cubed, rooted, whatever it might be, absolute value, and you set that equal to 0, and you solve it. Here we got x equals 3, so that means I'm going to shift my function 3 units to the right. Now keep in mind, if this was negative, you would just move to the left. For the second example, we got x equals 2, so I'm going to shift 2 units to the right. The way you determine the vertical shift is by taking these values you found for your horizontal shift and plugging them into your function. Here we took a 3 and plugged it in. We got 3 minus 3, which is 0, 0 squared is 0, and you got plus 4. On the second example, we got negative 1, and you can see from the functions, here we have a plus 4, and on the end we have a negative 1. Typically, your vertical shift is just what's ever being added or subtracted to the end of the function. Alright, so we're going to take a look at these 2 examples and a couple more. Alright, so for this first example, I've graphed the parent function f of x is equal to x squared, and we're going to base this graph off of that. We already determined there's a reflection over the x-axis, because the negative's on the outside. We're going to shift 3 units to the right and 4 units up. So for my vertex, I'm going to shift over 3 units to the right and 4 units up. And then from there, keep in mind it's going to reflect over the x-axis, so now this is going to open down. Just plot a couple additional points, and you're good to go. Right, let's take a look at this next example. We already determined, because the negative was on the inside, we're going to reflect over the y-axis. The horizontal shift is going to be 2 units to the right and 1 unit down. So now this point right here at the origin is going to shift 2 units to the right, 1 unit down. And since it's reflecting over the y-axis, it's going to open up and to the left, down and to the right. And so it'll look something similar to that. In this next example, we have the parent function, which is the square root of x. And we're going to look to graph f of x is equal to negative square root of x plus 2. The negative is on the outside, so it's an x-axis reflection, so this is now going to open down. There is, if we take x and set it equal to 0, that means there's no horizontal shift. And on the outside we have a plus 2, so I'm going to shift 2 units up. Alright. And keep in mind this is going to open down. Alright, and your graph will look something like that. The next one over here, we have an absolute value graph. The parent function here looks like a V. And we have reflection, because the negative is on the inside, we have reflection over the y-axis. Now, if we have reflection over the y-axis, this is actually known as an even function. Reflection over the y-axis, although it occurs, it reflects back over itself. So it does happen, but you just don't see it because it reflects back on itself. The horizontal shift, we take negative 3x plus 4, set that equal to 0. I'm going to shift over negative 4/3, which is just a little bit more than 1. And then I'm going to shift up 1 unit. So now my vertex has shifted negative 4/3 up 1. All right, and we know this is going to open up because it's a positive on the outside. And my slope has changed just a little bit. The slope is now positive 3. Well, for half of it, positive 3. For the other half, it's negative 3. So I'm going to go up 3 and over 1. And up 3 and over 1 to the other side. And that's your new graph. Right. The last example here, we have negative sign times the quantity x plus pi over 2 minus 2. Since the negative's on the outside, we're going to reflect over the x-axis. So here we have the parent function, sine x, and we're going to reflect over the x-axis. So all these hills are going to become valleys, and all the valleys are going to become hills. All right, we're going to shift. We took x plus pi over 2 and set that equal to 0, and we solved it. We're going to shift pi over 2 units to the left. So this point at the origin, picture this going to the left pi over 2 units. And then the vertical shift, we have minus 2, so we're going to shift 2 units down. So I'm going negative pi over 2, I'm going 2 units down. And remember, Where there were hills, there's now going to be valleys. So I started with a hill, so here I'm going to start with a valley. And then we're going to go into a hill. And then back into a valley. Oops. Alright, and then that'll continue on and on, like such.